Preface. If you are working in software engineering in recent years, especially in server-side and backend system, you have probably been bombarded with a plethora of buzzwords relating to storage and processing of data. NoSQL, big data, web scale, charting, eventual consistency, ACID, CAP, theorem, CAP theorem, cloud services, MapReduce, real-time. In the last decade, we have seen many interesting development in databases, in distributed systems, and in the way we build applications on top of them. There are various driving forces for these developments. Internet companies such as Google, Microsoft, Amazon, Facebook, LinkedIn, Netflix, and Twitter are handling huge volume of data and traffic, forcing them to create new tools that enable them to efficiently handle such scales. Businesses need to be agile, test hypotheses cheaply, and respond quickly to new market insight by keeping development cycles short and data models flexible. Free and open source software has become very successful and is now preferred to commercial or bespoke in-house software in many environments. CPU clocks speed are better increasing, but multi-core processors are standard and networks are getting faster. This means parallelism is only going to increase. Even if you work on a small team, you can now build systems that are distributed across many machines and have multiple geographic regions, thanks to infrastructure as a service, IaaS, such as Amazon Web Services. Many services are now expected to be highly available. Extended downtime due to outage or maintenance is becoming increasingly unacceptable. Data-intensive applications are pushing the boundaries of what is possible by making use of these technological developments. We call an application data-intensive if data is its primary challenge. The quantity of data, the complexity of data, or the speed at which it is changing, as opposed to compute-intensive, where CPU cycles are the bottleneck. The tool and technologies that help data-intensive applications store and process data have been rapidly adapted to these changes. New types of database systems, NoSQL, for example, have been getting lots of attention. But message queues, caches, search indexes, frameworks for batch and stream processing, and related technologies are very important too. Many applications use some combination of these. The buzzword that fills this space are a sign of enthusiasm for the new possibilities, which is a great thing. However, as a software engineer and architects, we also need to have a technically accurate and precise understanding of the various technologies and their trade-off if we want to build good applications. For that understanding, we have to dig deeper than buzzwords. Fortunately, behind the rapid change in technology, there are enduring principles that remain true. No matter which version of a particular tool you are using, if you understand those principles, you are in a position to see where each tool fits in, how to make good use of it, and how to avoid its pitfalls. That's where this book comes in. The goal of this book is to help you navigate the diverse and fast-changing landscape of technologies for processing and storing data. This book is not a tutorial for one particular tool, nor it is a textbook full of dry theory. Instead, we look at examples of successful data system technologies that form the foundation of many popular applications and that have to meet scalability, performance, and reliability requirements in production every day. We will dig into internals of those systems, tease apart their key algorithms, discuss their principles and their trade-off they have to make on this journey. We will try to find useful ways of thinking about data systems, not just how they work, but also why they work that way and what questions we need to ask. After reading this book, you will be in a great position to decide which kind of technology is appropriate for which purpose and understand how tools can be combined to form the foundation of a good application architecture. You won't be ready to build your own database storage engine from scratch, but fortunately, that is rarely necessary. You will, however, develop a good intuition for what your systems are doing under the hood so that you can reason about their behavior, make good design decisions, and track down any problems that may arise. Who should read this book? If you develop applications that have some kind of server backend for storing or processing data, and your application uses the internet, example web applications, mobile apps, or internet connected sensor, then this book is for you. This book is for software engineers, software architects, and technical managers who love to code. It is especially relevant if you need to make decisions about the architecture of the system you work on. For example, if you need to choose tools for solving a given problem and figure out how best to apply them. But even if you have no choice over your tools, this book will help you better understand their strengths and weaknesses. You should have some experience with web-based applications or network services, and you should be familiar with relational databases and SQL. Any non-relational database and other data-related tools you know are a bonus, but not required. A general understanding of common network protocols like TCP and HTTP is useful. Your choice of programming languages or framework make no difference for this book. If any of the following are true for you, you will find this book valuable. You want to learn how to make data systems scalable, for example, to support web or mobile apps with millions of users? You need to make applications highly available, minimizing downtimes, and operational robust. You are looking for ways of making systems easier to maintain in the long run, even as they grow and as the requirement and technology change. You have a natural curiosity for the way things work and want to know what goes inside major websites and online services. This book breaks down the internal of various databases and data processing systems, and it's great fun to explore the bright thinking that went into their design. Sometimes, when discussing a scalable data system, people make comments along the line, "Oh, you are not Google or Amazon. Stop worrying about scale and just use a relational database." That is true in that statement. Bidding for a skill that you don't need is a waste effort and may lock you into an inflexible design. In effect, it is a form of premature optimization. However, it is also important to choose the right tool for the job, and different technologies each have their own strengths and weaknesses. As we shall see, relational databases are important, but not the final word on dealing with data. Scope of this book. This book does not attempt to give detailed instructions on how to install or use specific software packages or APIs, since there are already plenty of documentation for those things. Instead, we discuss the various principles and trade-offs that are fundamental to data system, and we explore the different design decisions taken by different products. In the ebook edition, we have included links to the full text of the online resources. All links were verified at the time of publication, but unfortunately, links tend to break frequently due to the nature of the web. If you come across a broken link, or if you are reading a print copy of this book, you can look up references using a search engine. For academic papers, you can search for the title in Google Scholar to find open access PDF file. Alternative, you can find all the references at https://github.com EFTDDIE/references, where we maintain up-to-date links. We look primarily at the architecture of data systems and the way they are integrated into data-intensive applications. This book doesn't have space to cover deployment, operation, security, and management, and other areas. Those are complex and important topics, and we wouldn't do them justice by making them superficially side notes in this book. They deserve books of their own. Many of the technology described in this book fall within the realm of big data buzzword. However, the term big data is so overused and underdefined that it's not useful in the setting engineering discussion. This book uses less ambiguous terms such as single node versus distributed system, or online interactive versus offline batch processing system. This book has a bias toward free and open source software, FOSS, because reading, modifying, and executing source code is a great way to understand how something works in detail. Open platform also reduces the risks of vendor lock-in. However, where appropriate, we also discuss proprietary software, closed source software, software as a service, or company in-house software that is only described in literature but not released publicly. Outline of this book. This book is arranged into 3 parts. In part 1, we discuss the fundamental ideas that underpin the design of data-intensive applications. We start in chapter 1 by discussing what we are actually trying to achieve: reliability, scalability, and maintainability, how we need to think about them, and how we can achieve them. In chapter 2, we compare several different data models and query languages and see how they are appropriate to different situations. In chapter 3, we talk about storage engines, how databases arrange data on disks so that we can find it again efficiently. Chapter 4 turns to format for data encoding, serialization, and evolution of schemas over time. In part 2, we move from data stored on one machine to data that is distributed across multiple machines. This is often necessary for scalability, but brings with a variety of unique challenge. We first discuss replication in chapter 5, partitioning charging, chapter 6, transactions, chapter 7. We then go into more details on the problems with distributed system, chapter 8, and what it means to achieve consistency and consensus in a distributed system, chapter 9. In part 3, we discuss systems that derive from datasets from other datasets. Derived data often occurs in heterogeneous systems when there is no one database that can do everything well. Application needs to integrate several different databases, caches, indexes, and so on. In chapter 10, we start with a batch processing approach to derive data, and we build upon it with stream processing in chapter 11. Finally, in chapter 12, we put everything together and discuss approaches for building reliable, scalable, and maintainable applications in the future. Reference and further reading. Most of what we discuss in these books has already been said elsewhere in some form or another, in conference, presentations, research paper, blog posts, code, books, tracker, mailing lists, and engineering folklore. This book summarizes the most important idea from many different sources, and it includes pointers to the original literature through the text. The reference at the end of each chapter are a great resource if you want to explore an area in more depth, and most of them are freely available online. O'Reilly Online Learning. O'Reilly, for more than 40 years, O'Reilly Media has provided technology and business training, knowledge, and insight to help companies succeed. Our unique network of experts and innovators share their knowledge and expertise through books, articles, and our online learning platform. O'Reilly Online Learning platform gives you on-demand access to live training courses, in-depth learning path, interactive coding environment, and a vast collection of text and video from O'Reilly and 200 plus other publishers. For more information, please visit http://O'Reilly.com.